So you want to learn Blender in 2025. You clicked on the right video. Whether you are an absolute beginner or just getting back into 3D, this is your ultimate crash course. We'll go through all the essentials: navigation, modeling, texturing, lighting, and animation, while creating a sci-fi hallway. By the end, you'll have a complete scene and the confidence to explore more on your own. First things first, let's get Blender set up. Go to blender.org and grab the latest version. It's free, open source, and constantly improving. It runs on any decent computer, but if you have a good GPU, things will run even smoother. It might look overwhelming at first, but don't worry, it's actually pretty simple. Right in the middle, we have the 3D viewport, where all the magic happens. On the right, there's the outliner, where all your objects are listed. On the top here, you have the different panels: layout, modeling, UV editing, texture painting, sculpting, etc. And at the bottom, you have the timeline, which is useful for animation. Now let's get moving. In Blender, navigation is super easy. Hold the middle mouse button to rotate. Scroll up and down to zoom in and out. Also, you can press Ctrl and middle mouse button and move your mouse up and down. Press Shift and the middle mouse button to pan around the scene, and just the middle mouse to orbit around your object. On the left over here, we have our tool panel, where we have the move, rotate, and other tools. But for basic transformation operations, there are keyboard shortcuts. Press G to grab an object and move it. Press G followed by X to move it along the X axis, Y to move it along Y, and Z to move it along the Z axis. Select the object and press R to rotate the object along view. Press R 2 times for free rotation. And press R followed by axis to rotate it along X, Y, or the Z axis. We're almost done with the navigation controls. One final thing, you can press and hold Z to shift along different views like wireframe, material preview, solid view, rendered view. But for the most part, we'll be working and modeling in solid view. Now let's start building a very simple sci-fi corridor to take you through all the basic functions inside of Blender. Follow along with me and create your very first scene. Press G, Z and 1 to bring your cube to the origin. Now S, Y, 2 to scale it 2 times along the Y axis. Now we need to shape this into a corridor. In Blender, there are two main modes that we use while modeling. One is object mode and the other is edit mode. Press tab to go into edit mode and tab to get out of it. In edit mode, press 1 to go to the vertex select mode, where you can manipulate individual vertices. 2 to go into edge select, where you can edit edges. And 3 for face select mode, where you can extrude, edit faces. For our corridor, let's select the two faces of the cube on the long ends and delete them by pressing X and choosing faces. Now let's further divide this mesh into separate parts for more editing. Press Ctrl R to add loop cuts, which divide the mesh into equal parts. Scroll up to increase the number of loop cuts, scroll down to reduce it, and click to confirm. Now I selected all the side faces of the corridor, and you can press I to insert the faces. When multiple faces are selected, they all insert together, but if you want to insert them individually, press I and I once again to insert each of the faces individually. Now we can just press E to extrude, but since we have faces selected on the opposite ends, that won't work. Press Alt E to open the extrusion menu and choose extrude faces along normals, which lets us extrude the faces inwards or outwards along its normal, that is the perpendicular direction. I'll extrude the faces a little bit inwards here. We'll use more insets, extrusions and loop cuts to create depth and interest. I selected the floor panels, insert them and pressed E to extrude them a little bit downwards to create an indented floor. Then I proceeded to add loop cuts on the side wall panels and increased the number of loop cuts by scrolling up. After adding horizontal loop cuts, I selected the individual panels and added vertical loop cuts as well. And then I selected certain areas of the panels and added random number of loop cuts because I wanted to insert and extrude certain random faces in the walls. I selected certain faces in different parts of the panels and extruded them inwards or outwards to create depth and break up flat surfaces. There are procedural ways to do this, but for the scope of this beginner tutorial, I'm just keeping it simple by just manually selecting and extruding faces inwards and outwards. After about 2 minutes, I had some decent looking panels on the walls. Then I wanted to add some lights on the ceiling as well. For this I added more loop cuts on the ceiling. When you press Ctrl R to add a loop cut, you can even move it around. Pressing just Ctrl R and clicking will add a loop cut in the center of the face. I selected some faces alternating with gaps in between them to make the lights on the ceiling. After selecting the faces, I just extruded them downwards and press Ctrl B to add a bevel. Whether you're scaling, rotating or beveling, pressing Shift will give you more precise control when you're moving. Let me tell you more about beveling now. Select a cube and go into edit mode and select certain faces and press Ctrl B. You can bevel the edges to get rid of perfectly sharp corners. After beveling, you can also scroll up or down to increase the number of segments in the bevel and scroll back down to reduce the number of segments. It's a very handy tool because perfectly sharp corners do not exist in our world. Next, I selected the edges on the floor of the corridor by using box select. Pressed Ctrl B and beveled it very slightly by holding the Shift to create a small face, and then press Alt E to extrude it along normals, upwards or downwards. I extruded it downwards to create some ridges in the floor, which could be like an anti-slip feature. On the right below the outliner, you have your side panel where you have your different settings such as rendering settings, output settings, modifiers, material settings, etc. Modifiers in Blender are like superpowers for your models. Instead of doing everything manually, they let you cheat time, duplicate, smooth or reshape things without actually editing the model. Think of them as non-destructive magic tricks that make 3D modeling way easier. Let me show you a couple of modifiers so that you understand. Duplicate a cube and add a Boolean modifier on one of the cubes. Select the target object as the other cube. Now when you move the second cube over the first one, well, nothing happens, but if you hide the second cube, you can see that it is cutting into the first cube. Move it elsewhere and scale it down or up and hide it once again to see the modifier in work. You can also apply these modifiers to finalize it. Let me show you another modifier, such as the mirror modifier. After applying a mirror modifier, if you go into edit mode and move your object, you can create two identical copies of your object and model things easily by duplicating them in real time. Because you need to model two towers or two engines or tanks, whatever. So now we are going to use some modifiers on our model to create the final corridor. First, add a solidify modifier. This increases the thickness of your model inwards or outwards depending on your value. In this case, the positive scales it inwards and negative scales it outwards. So scale it slightly in the negative value to give it some thickness. Now let's look at the workspaces on top. We have the layout workspace, modeling. These different workspaces are built for different tasks. For example, the sculpting workspace is built for sculpting details onto your objects. There are more advanced workspaces like UV editing, texture painting, but will not go into that for the scope of this video. Click on the shading tab to step into the shader editor. Here we can give materials to our objects. Select your object and click new to give it a new material. Down here we have the shader editor, and a new material gives us the principal BSDF, which is the basic material type in Blender. Here we have the base color, which is the color of the material, and the metallic slider, which increases the metallicness of the material, or the roughness, which makes a material more rough or smooth and reflective. We have many more options below, which we'll explore slowly. Let's select the base color and make the color a dark gray. Want this to be metallic, increase the metallic slider all the way up and reduce the roughness to make the material a little bit reflective. You can adjust the settings like roughness according to the look that you want. We can also assign different materials to different parts of the objects by selecting them in edit mode. Go to edit mode, select the floor by box select and make sure you're in face select mode. Then go to the side panel on your right and click on the material properties. Click plus to add a new material and then click on new. assign the selected part of the mesh to the new material. Now you can change the color of this material, metallic properties, roughness properties, etc. We have successfully assigned two different materials to our mesh. I also want to add some emissive lights to the side walls, so I selected the faces between the panels of the walls in edit mode and assign them a new material. You don't need to change the other properties. Go down to emission, click on it and increase the emission strength to give it an emissive material. This makes the material emit lights from the faces in our chosen color. But we can't really see the light interacting with our mesh. So let's go into rendered view and learn more about lights and rendering engines. You can press Z and select rendered view or click the rendered option on the top right of your viewport. In a default Blender scene, you are greeted with a cube, a point light and a camera. By default, Blender opens in the rendering engine Eevee, which is its own real-time rendering engine, and the other is Cycles, which is a physically accurate, path-traced rendering engine. If you have a good GPU, make sure to shift to GPU compute under device in Cycles rendering to get the best of your GPU. The point light is just like a small LED bulb that we have in our houses. You can add more lights by going down to the add menu and choosing the other lights. The second type of light is a spotlight, which is basically how it is in the real world. You can increase the power to get a spotlight. The third type of light is an area light, which is more like a LED light panel or a diffuse softbox, which comes very much in handy while lighting our scenes. You can increase the size of an area light, increase the power to make it brighter like the other lights, or even change the shape to rectangle, ellipse, etc. The final type of light is the sunlight, which is basically emulating the real life sun. You can increase the strength and rotate it on an axis to change the angle of the sun and how it's hitting the surface. Another handy tool while lighting scenes are HDRIs. Go into Edit, Preferences, Get Extensions and search for Blenderkit and install the add-on. Once you install it, you will have access to thousands of free 3D models, materials, whole 3D scenes to use, HDRIs, brushes and a lot more to choose from. So what is an HDRI? High dynamic range image are a set of bracketed images taken at multiple exposures ranging from low to high and recreate the actual lighting conditions of the location of the HDRI. I just dragged a free HDRI into the scene and this gives us lighting all around the object. But in Eevee, it's not that apparent. If you switch to Cycles on the other hand, since it's not faking like Eevee and it's a physically accurate engine, we get way better lighting, shadows and global illumination. In short, Eevee is very good for real-time visualization or stylistic renders, but if you want to go for photorealism, you better choose Cycles. In edit mode, I also selected the lights we extruded before and gave them an emissive material. You can see in Eevee by default it doesn't look that great because it doesn't have shadows and global illumination by default. If we turn on ray tracing in the newest version of Eevee, which is Eevee Next, it gets a little better, giving us a slightly more accurate lighting and reflections. But you can see the moment we switch to Cycles, it makes all the difference in the world. The shadows, lighting and also global illumination from the emissive lights looks way better in Cycles. An important tip, while working in Cycles, make sure to rename your materials, meshes, etc. so you don't get lost in dense projects. You can select the material assigned to any object and press the copy option beside the name to make a new material copy. And then you can change its properties, for example to give different colored emissive lights on the wall panels and leave it white for the ceiling lights. This helps us by not having to reconstruct complex materials every time if we have to make small changes. Now we have a small section of the corridor ready, but we need to extend it. So let's go back into the layout mode and add an array modifier. The array modifier lets us duplicate this hallway section automatically, saving tons of time. You can increase the count to increase the number of repetitions, and if the model is not extending in the right direction, you have to probably change the factor from x-axis to any of the other axes. Increase the count to a high number to make a long corridor. Now let's add a camera and frame our scene. Press Shift A to go into the Add menu, type and search camera to add a camera into your scene. Now you can use G to grab and move the camera like before. Press 0 on the numpad to snap your view to camera. When you're in the camera view, you can press G to move the camera or R to rotate the camera. The best feature is the flyby feature. Press Shift plus the tilde key to fly by in the camera view. You can use WASD to move around, Q and E to go up and down in the camera. This is a very quick and easy way to move around your scene and position your camera easily. Side panel and click on the render settings. Our resolution is set to 1920 by 1080. Let's change it to 1080 by 1080 for now and use the camera flyby feature to frame your shot. When you're in the camera flyby view, scrolling up will increase your moving speed and scrolling down will reduce your moving speed. Also, when your camera is selected, you can find the camera options in the side panel. Here you can change the focal length. I'll set the focal length to about 35 for this shot. You can also shift the camera sensor on the X or Y axis if you want. There are many more features to explore here, but one of the very important features is depth of field. Go to the viewport options on the top right and select depth of field to enable it in your viewport. Now you can increase or decrease the focus distance to focus on farther parts or closer parts of your image. You can also use the eyedropper in the focus object to select an object that you want to focus on. The f-stop option below controls the shallowness of the depth of field. Lower f-stop gives us a blurry image outside the focal plane and a higher f-stop gives us a sharper image. You can also come down to the viewport display and select from different composition guides like thirds, center, diagonal, ratio, triangle, etc. to frame your shot according to cinematic composition guides and ratios. For fine-tuning the location, rotation of any object, go to the object properties and you can enter precise location, rotation and scale values on X, Y and Z axis for more control on your scene. I brought in an HDRI from Blenderkit to add some ambient lighting to our scene. Optionally, you can model a wall structure and place it at the far end of the corridor so we do not see through the other side. Next, let me show you the basics of animating anything in Blender, that is by adding keyframes. I'll add a cube to demonstrate this. Make sure you're in the beginning of the timeline and select your object. Press I to add a keyframe. Now, the location, rotation, translation are all keyframed, and if you move the object without setting another keyframe, it will come back to this position always. Move forward about 30 frames and move the object and add another keyframe by pressing I. Now when you play the animation from 0 to 30 frames, you can see that your animation is interpolated between these two keyframes. We can also change the interpolation mode by selecting the keyframes and right-clicking and choosing interpolation mode to linear, Bezier, quadratic, etc. Let's select our camera and add some camera animation. You can move to the beginning of the timeline in your project by pressing Shift and the left arrow key. Set a keyframe for your camera at this frame. In video and animation, everything works on frames per second. So if you go to the render settings, you can select the frame rate, which is 24 usually, or you can go for 25, 30, 60 or any other frame rate that you want. Since I don't want to render a very long scene, I'll set the timeline start to 1 and end to 120, 24 into 5, which is 5 seconds. Press Shift and right arrow to go to the end of your timeline. Shift and tilde to go into the camera flyby. Move forward in your camera and set another keyframe at the end by pressing I. If your camera flyby speed is too high, you can scroll down, or if it's too low, you can scroll up to change the speed of the camera flyby. For a quick overview of your scene, you can press 1 to go into the front view, 3 to go into side view, or 7 to go into the top view, and use the other numpad keys to rotate between the different views. Now all that's left is to render our scene. For this you need to save your file. So press Ctrl S to save your project, because we can't hit render without saving it. Let's also check the output settings. You can go down to output here and select the folder where you want the output. File format PNG is usually fine for personal renders, but if you want to be working in a professional pipeline, you would probably want to go with OpenEXR. File format, choose PNG, and the color modes, RGB is for normal colors, BW for black and white obviously, and RGBA, which has an alpha channel if you want to export something with transparency. There are more export options that you can look into yourself. Hit F12 to render an image. Whether you're in Cycles or Eevee, you need to set the render samples. Render samples in Blender determines how many times Blender calculates lights per pixel in an image. If you're working with Eevee, the default render size of 64 works, but in Cycles, it's usually 4096, which is a very high number, so you can reduce it to 100, 200, 400 samples as your scene requires. When you're in Cycles, make sure to turn off the light tree option under lights in the render settings for faster renders. And if you're in Eevee, make sure to turn on ray tracing for more realistic renders. This is how a render looks in Eevee. And let me render the same scene with Cycles now. Set it to Cycles, reduce the number of samples to 200. Press F12 to render a still image. So turn on the denoise feature in both viewport and rendering to reduce the amount of noise and get crystal clear renders. So these are the basics of navigation, modeling, texturing, lighting, and rendering in Blender. I hope this video satisfies your curiosity and gives you a nice starting point to explore more things and learn new things in 3D and Blender. If you want to learn more about sci-fi modeling or watch my originals coming soon, subscribe and check out my other tutorials. Hope you enjoyed this video and let me know how I can improve in the comments below. Follow and subscribe for more videos every week.